8 stages of a systematic review and meta-analysis. 1. Formulate the review question. The first stage involves defining the review question, forming hypotheses, and developing a review title. It is often best to keep titles as short and descriptive as possible, by using the following formula: intervention for population with condition. Reviews published with the Cochrane collaboration do not need to be identified as such, but reviews published in other sources should also indicate in the title that they represent a systematic review and/or meta-analysis. If authors chose to conduct their review through the Cochrane collaboration, they will also be required to register their title to the appropriate review group, which in essence saves their spot for this topic and provides access to further Cochrane support. 2. Define inclusion and exclusion criteria. The Cochrane acronym PICO, or PCOC, which stands for Population, Intervention, Comparison, Outcomes, and Context, can be useful to ensure that one decides on all key components prior to starting the review. For example, authors need to decide a priori on their population age range, conditions, outcomes, and types of interventions and control groups. It is also critical to operationally define what types of studies to include and exclude, for example, randomized controlled trials RCTs only, RCTs and quasi-experimental designs, qualitative research, the minimum number of participants in each group, published versus unpublished studies, and language restrictions. For Cochrane reviews, this information gets prepared, peer-reviewed, and published in a protocol format first, which is then replaced with a full review once it is completed. 3. Develop search strategy and locate studies. This is the stage where a reference librarian can be extremely helpful in terms of helping to develop and run electronic searches. Generally, it is important to come up with a comprehensive list of key terms, i.e., MeSH terms, related to each component of PCOC to be able to identify all relevant trials in an area. For example, if the age range is 13 to 18-year-old females, search terms may need to include any of the following: adolescents, teenagers, youth, female, women, girls, etc. The key in developing an optimal search strategy is to balance sensitivity, retrieving a high proportion of relevant studies, with specificity, retrieving a low proportion of irrelevant studies. Searches generally include several relevant electronic databases but can also include checking article reference lists, hand-searching key journals, posting requests on listservs, and personal communication with experts or key researchers in the field. 4. Select studies. Once a comprehensive list of abstracts has been retrieved and reviewed, any studies appearing to meet inclusion criteria would then be obtained and reviewed in full. This process of review is generally done by at least 2 reviewers to establish inter-rater reliability. It is recommended that authors keep a log of all reviewed studies with reasons for inclusion or exclusion, and it may be necessary to contract study authors to obtain missing information needed for data pooling, for example, means, standard deviations. 5. Extract data. It can be helpful to create and use a simple data extraction form or table to organize the information extracted from each reviewed study, for example, authors, publication year, number of participants, age range, study design, outcomes, included/excluded. Data extraction by at least 2 reviewers is important again for establishing inter-rater reliability and avoiding data entry errors. 6. Assess study quality. There has been a movement in recent years to better assess the quality of each RCT included in systematic reviews. Although there are brief checklists available such as the 5-point Oxford Quality Rating Scale commonly used in Cochrane reviews, this measure is heavily influenced by double blinding, which is appropriate for drug trials but generally not for psychological or non-pharmacological interventions. There are other more comprehensive recommended guidelines and standards available such as the Consolidated Standards of Reporting Trials, as well as articles providing recommendations for improving quality in RCTs and meta-analyses for psychological interventions. 7. Analyze and interpret results. There are various statistical programs available to calculate effect sizes for meta-analyses, such as the Review Manager, RevMan, program endorsed by the Cochrane collaboration. Effect sizes are stated along with the 95% confidence interval, C, range, and presented in both quantitative format and graphical representation, for example, forest plots. Forest plots visually depict each trial as a horizontal diamond shape with the middle representing the effect size and the endpoints representing both ends of the C. These diamonds are presented on a graph with the center line representing the 0 mark. often the left side of the graph, and LT, 0, represents the side favoring treatment, while the right side, and GT, 0, represents the side favoring the control condition. At the bottom of the graph is a summary effect size or diamond representing all of the individual studies pulled together. Ideally, we would like to see this entire diamond effect size in both anchors of the C falling below 0, indicating that the intervention is favored over the control. In addition, most programs also calculate a heterogeneity value to indicate whether the individual studies are similar enough to compare. In this case, it is preferable to have non-significant findings for heterogeneity. It is still possible to pool studies when significant heterogeneity exists, although these results should be interpreted with caution or reasons for the heterogeneity should be explored. As with all papers, the last step in the writing process involves summarize the findings, and providing recommendations for clinical work and research. 8. Disseminate findings. Although reviews conducted through the Cochrane collaboration get published in the online Cochrane database of systematic reviews, they are often quite lengthy and detailed. Thus, it is also possible and encouraged to publish abbreviated versions of the review in other relevant academic journals, as long as they are clearly indicated as such. Plain language summaries for families and patients are also commonly provided, and there is an expectation that reviews should be regularly updated to ensure they are always up to date and relevant. Indeed, participating in a review update or joining a well-established review team can be a helpful way of getting involved in the systematic review process.